AM is revolutionizing the way we create objects, from prototypes to final products. Let's explore how this technology works and impacts on various industries.
Please take the time to subscribe, like, and share if you are interested.
Additive manufacturing is all about building objects layer by layer. Unlike traditional manufacturing methods, which often cut away material from a larger block, AM adds material only where it is needed. Unfortunately, this comes at a cost of resolution, like we see in the examples here, where you see it not matching perfectly with the shape you're trying to achieve. Types of 3D printing technologies, each with its unique capabilities. We will look at each of these in more detail as we move forward, but to start with, let's look at a little bit of a background about what each method is and how they generally work. First, we have fused deposition modeling, which uses melted plastic filament to build up layers, very much like typically would be purchased if you want to do something like a 3D print in your own house. Then you have binder jetting, which uses a binder material to fuse material together, followed by a secondary sintering process. Then you have direct ink writing, which uses a viscoelastic ink to extrude material, which also requires a secondary process to make the structure solid. You have stereolithography, which employs a laser to cure liquid resin into solid layers. Selective laser sintering and selective laser melting, which uses a laser to either fuse powdered materials together or outright melt them together. And then you have digital light processing, which is similar to the stereolithography methodology, but uses a digital light projector for faster curing. This can be done with visible light or with UV lights. It has quite a few benefits that can make it quite useful as we move forward. The first of this is customization. You can make the product tailored to what's needed. You don't have to subtract material. You don't have to worry about excess amounts of waste. You can use it really nicely for rapid prototyping, for quick iterations and testing. You can generate complex geometries, intricate shapes that are difficult or even impossible to manufacture through traditional methods. And then there's the concept of dispersed manufacturing, where you can take the idea that instead of having a manufacturer leading to a distributor and then consumers buying from the distributor, the consumer is the manufacturer now, in that they can manufacture the components that they need. Advantages: AM still has quite a few challenges that it needs to address. The primary of which is the high initial costs. Systems are not cheap. You can buy relatively low cost systems for a few $100, but the downside is they don't have the resolution that you may want or the materials capable of being printed on the particular cheap system that you want to use in order to obtain what you're looking for. So while things are being worked to address these, we still have high costs, material limitations. You can't print every material that exists. You can only print certain ones, and certain processes only work for certain materials. The material costs are costly to extremely costly depending on the process you're working with, where polymers like you do for FDM type printers are relatively cheap, but if you go onto your selective laser melting process for additive, and for metals, then you're going to be looking at some really high costs, and it shoots up exponentially. You also have relatively low throughput, which means if you consider the value of printing, you have your benefit of customization, but you can't make a lot of parts fast with a single machine. You would need a lot of machines in order to do that, and it takes a significant amount of time, hours to days for some fairly simple geometries. From everyday items to cutting-edge innovations, additive manufacturing is shaping the future of production. If you're curious to learn more or see AM in action, subscribe to our channel and stay tuned for more exciting content. Thanks for watching. Don't forget to like, comment anything you'd like to see more about, and share. See you in the next video.